all and almost uh, all frames are designed as moment resisting frames. And in that case, I think our structures are I would say can I say, or I would like to say that it's a very strong structure. Okay, except that there will be no liquefaction. Okay, of course, from our earthquake engineering, if there is a liquefaction, then I think there's a problem with in the foundation. So again, let me trace. Okay, let me trace because let me trace back what we have discussed for the past four encounters fundamentally for our design report. Okay, how we are going to do the design, and that also I'm saying that it's our first, it's your first. Okay, it's your first experience in the design. Okay, and that in that design you are going to trade off many things. Okay, many things. I also said that mandatory trade-off for columns are when you consider it tied in spiral things. I may ask you now, what are the things that you would like me to discuss with you? Because earlier I said, how are you going to understand if it is not discussed with you, especially it's not part of our reference material. Anybody? So mandatory trade-off on columns to see if you do tied columns, spiral columns. Even did not have we even did not have a spiral column in our assessments, or even in in our examples. Okay, but I would like you to please check on that. Our final exam is covers. There are four. There are four problems in our final exams, and that it covers everything from the start to finish. Okay, but I think I will not be doing multiple choices. Okay, it's computational, of course. You know that. So tied columns versus spiral column. Now notice that in the spiral column, now in the columns and beams are part of our frames. These are part of our frames. So silence may does it mean that silence is that you understand? Well, let's try this. So I would like you to please understand. Now, this is to me a very nice experience. Very nice experience for all of us, especially if you're going to do it. You model that one. I know that it will take us time to do moment distribution method, or if you want slope deflection method for the frame, because it will take you a lot of time. Even me, I think I will not do that. So instead, I said that you are going to use stud, and I would like to know now if, okay, anyway, Malati already said that he's just doing something more on the stud, okay? I hope that you are there already, okay? It's very, uh, it needs time, okay? So, our today is our 14th week. To submit that one on the 15th. Initially, I said Thursday because of the clamor of some of our students, and I see that they are valid, and let's do it for everyone. Let's do it on Saturday. Okay? Saturday. What date is that? Bakudio. Bakudio. What date is that? Saturday.
11 po ata.
Thanks. Okay. Welcome. So, students, I'm appealing to you. I'm appealing to you that I would like you to study more, study well. It's for you. Okay, it's for you. Um, if if you want to know our record in our civil engineering licensure exam is current, it's saddening. It's sad to know that. Yeah, welcome everyone. It's sad to know that we failed. We failed in our newly uh, newly uh, newly grad students who took the licensure exam. The the repeaters made it. They are above the national passing percentage for the repeaters, but for the newly grad students who took the licensure exam, they were not able to make it. Okay, so that's why we were below. The national passing percentage is 36 point something percent, and that ours is only I think 22 or 28. You can see. Do you know what could be the reason? I think you know the reason. I don't have to elaborate so much on that. Okay, it's for you, my dear students. All right, it's for you as your program chair. It's on my shoulders how we can make these things happen
Wala bang
for all
cellphone tong...
of you, for all of
Sino ba to?
us.
Jessica na to?
Everyone
Wala bang
will
ano yan?
surely pass.
Kasi
What
kung
I'm saying
cellphone niya
will
yan,
surely
mag-text lang sa
pass.
kanya.
I think
Ay magte-text
first
sa
and
kanya automatic
foremost
yung resibo.
that should come from you. If we are doing all these things right now, and that I said that part of the submission here is that you are going to submit
Yung picture.
manual design. Okay, many times I said this. Okay, manual design of all your design. Okay, manual
Picture
design.
naman kanina yung resibo.
Many times I said that. Okay, many times I said that.
Malabo daw?
In that you are going to do this
Okay.
only present. Okay, only present or two depending on the category of the problem. If only all our students are doing this, I think all of us are immersed in doing calculations, and I think you have a very good fighting chance during the licensure exam. I think this is the best way to do these things. Okay, now you please doing this. Okay, start doing the calculations, because when you don't have this, you have a lot of deductions. Okay, because first you do not follow instruction. Okay, I'll repeat. Okay, I'll repeat. Okay, maybe you will wonder that you did not make it in this class because I also have you also have your what we call this design report. Okay, but as I've said many times, many times already. Okay, I'll repeat. Okay, you're doing this in Staad. Okay, all the models that you are going to do, you do it in Staad so that you can easily just get all those, whether it's axial, whether it's torsion, whether it's shear, whether it's flexure. Okay, the purpose is to enable you to get those numbers. Okay, that's for you. Okay, I would like everyone. Okay, welcome. Okay, thank you everyone that you got my point. This is for all of us. As I've said many times, if you will pass, and your parents will be 100% happy. But I'm more happier as your program chair because it's not only that you are with me on today or during this class of reinforced concrete design. It's only now that I'm handling this course. This I have been doing just the lower courses, but I'm trying to. I'm also trying to help our students. What do you mean by help? Um, I think uh, saying that you will fail. Never think about it. That's why I'm always positive that everybody uh, gets it. Everybody will do it. Everybody will proceed to the next level. But look at that. Look at that. It would be better if you have it this time. I think I myself I used to call it creative delay for our students. What is creative delay? Some of our students are, you know, they are, how can I describe them? They are late bloomers. Sometimes some of our students only get their best when they fail. As I've said, some of our students who top the licensure exam, I'm not saying it's because of me. No, it's not. It's all our department. We help each one of us to get you through the licensure exam. That's our thing. Okay, and of course we are sudden. I especially me because I'm your leader, and that if our students cannot make it through the licensure exam, let us pause for a while and think about it. What could be the reason? What could be the reason? So when when you are with me and sometimes you did not make it, I would say it's a creative delay. You'd rather have it, you'd rather fail here rather than in the licensure exam. And also, the best way to do that is you always have that mindset of I'm going to make it, I'm going to make it, I'm going to make it. But when you do that, when you do those positive affirmations and that you have not done anything, I think kumbaga sa atin sa Tagalog, taliwas yun, di ba? Taliwas. So again, kailan lang lumabas yung licensure and that it's sad, okay? It's sad. Get this. We can easily just get. Now what about this? Like ASFY. What about this? 0.85 A prime C. Is that right? So you can lay out that. You can lay out these equations. So you just have to look at all those things that we have discussed and apply that. Okay? That is when it's only tension. Now what if you are going to consider now all of these are hypothetical. So how am I going to check your word? I hope that I'm going to have all these things recorded. We have recorded this. So how do we check our work? That is that you have gone through this hypothetically comparing comparing what if this one is this, what if this one is that. Okay, just for um, computation uh, of this design. Okay, now is that mu the one that you are going to take here? Think about it. Okay, so I have all records of what we're doing. All right. That's how I would like to see it. Okay, please check some of our students, the one that I gave to you, the one that we also have in our resource materials. Please look at how they do it. But okay, we cannot we cannot do all of this for the entire just all of this. Okay, I would like you, once you have done this, then you will now be able to create a spreadsheet for this. Okay, is that clear? I'll repeat. Okay, I'll repeat, and that it's part of our submission. Okay, so this one is repetitive. We know that before you can do start will ask you of the geometry of the beam, column, slab, and and uh, and why do we still have to do this? Why do we still have to do this? Anybody? Why do we still have to do this? So, question here. Any question? Maybe I hope that you are not confused. Okay? Any question? And I asked Ruth Salino, are you there? So essentially, we're getting those numbers from our structural analysis using STAAD. Do you know how to get the forces from STAAD? There, Malate. Here yet. Anybody? Do you know how to do that? So we do, I think, much better now if we do that 50-50. I'm thinking about 50-50 for the last, when I mean 50-50, 50 for, you can see we have 6 hours for our design report, 50 for that, and 50 also for our major exams, and also that includes our quizzes. Okay, so that can be, if you have a good one, I think good design report, somehow that can help. Okay, somehow that can help. Sarambao, do you know how to get the forces in STAAD so that you are going to use that one in our manual design? Anybody? Anybody would like to volunteer? How are you there? Right, so meaning some of our students are not here. So where are they? I Start will give that one to you and all the moments. Okay, you just have to get the moment and in that. Do you understand what I'm talking? I do not know. Okay, I do not know if you understand. I do not know if you understand. But you have to say. So again, this is our fifth meeting for discussing this, and I think we just give justice for the entire 6 units. Okay, okay, this is our fifth meeting for this. So we have um, okay, we still have time. Okay, let's have a break at 5 minute break or 5 minute break at three. Um, we're going to do a discussion of the slab. If you don't have any questions anymore about this, okay. So let's have a break. Take your snap. Performance indicators for those, and how are we going to put them together? So I think what we have from above is this first table only. Okay, that's the first table. So how do we do this? To tell me if I'm not able to. Okay, so this is the raw data. You have, for example, design. You have your design one, two, three. So this can be likened to our what we call trade-off. And this one, PC1, PC2, PC3, and so on. And here in this example, we have four constraints. Okay,
Pili ka nga dito.
one, two, three, four, five constraints. Five constraints.
Ano?
We have to know how much is design one. For example, you are talking about you're talking about talking about a
Ah.
a trade-off in terms of framing. Okay, framing. Thus, framing is undoubtedly part of the building design. So we have gravity. Now we have also LFRNs. So then we compute that. We compute that. Okay, how do we compute this? Do you know how to do that? I think you know how to do this. So I think in doing this, just have to get a representative sample. Say for example, if you have a frame and that is a 5-story frame or whatever is that, then maybe we can, I would say, compute that design. Say, for example, that's why it's important that we have an initial design, and then we finally do that. Finally do that one in chapter 4. Now, if you can get a data like what we have from Max Fajardo. Are you familiar with Max Fajardo, where we have um, numbers to multiply or whatever we can do so that we'll be able to get the number of bags for cement and so on and so forth. That's how we do that. Okay, this is how we do that. For example, another trade-off for the floating. So you try to do uh, perhaps per square meter of per square. You can do entirely first. Anyway, it's just a. Right. Have to draw for a while, okay? Example, I think it can be also a thing that you just do, okay? You just do not do how to do. See, for example, that one is overall, it's what? It's 30 meters or 75 meters, 24 meters. So that's the entire slab. So do you think we can just design 1 meter by 1 meter? Or maybe we can do this all throughout. Then we get if that is your slab, okay? So if that is, say for example, 180, okay, 80 mm. For example, okay, I have a design supposedly discussed with you, but I would like to discuss it to you because maybe you don't have much time to do these things. So this is your thickness of the slab, and that, of course, you have gone through how much is this, why you were able to say it's 180. So you can say thickness is equal to L over 20. That's our technical side. So you want now to do that. So as the area is equal to 75 multiplied by how much is that? Say for example that is 25. 25 25 square, that is in terms of square meters. All right, and also get representative, just like what we do for one-way slab that you have to take 1 meter strip or 1,000 millimeters so that you'll be able to get, because it's a continuous thing. Okay, say for example, if this is top view. Okay, this is top view. So that's top view. Pardon me of that. Okay, if I make some notes here. Okay, so you can say how much is concrete for this one-way slab. Maybe you can say it's how much is the quantity. Say for example, because you need that kind of parameter. Concrete, okay, concrete for one way. So you're talking about how much is that in terms of pesos per square meter, okay, per square meter. So you have to get how much is the concrete volume, okay, and so on and so forth. I think you know how to do this one from your construction project management, no? So you have to have your cement, sand, gravel. Okay, you also have to do one way. Okay, one way slabs. So how do we do that? Then and please tell me if I'm out of your range. Okay, say for example, just an example. Okay, this is 1,000 mm. One is 180. So you can get the volume here. Okay, so that area, that is when you design. Okay, that is when you design for one way. Okay, so we will discuss that. So a which we have done already, multiplied by 0.180. Then so you have your volume. Is that correct? So on and so forth for this. So you have your concrete, have your you have your rebar, you have your formworks. But I hope that you have these parameters already from your capstone design one. Do you understand when I say parameter?
Okay lang, di
So
ka
that
malaman,
if you have this area, that can be good. Okay, that can be good if your costing for example for the flooring is equivalent to either per cubic meter or per square meter per meter. But no, I'm sorry. I'm talking about per square meter. Pesos per square meter. But I think the downside here, the drawback here, is that you still have to categorize what thickness. Did you get me? So for the bars, I think if you can get, if only you can get from anybody, okay, I would like you to, if ever you can get that one from, say for example, EAI, if they can give it to you, their parameters of computing it, then I think it would be faster. But if not, I think to me there's no problem. So you can do what I'm showing to you right now. So that's how you're going to do this. Now for the duration that you know how to do scheduling. I'm not be so much keen on this in this class in this reinforced concrete, except that if you're in the capstone design, then I would ask you to, of course, even if it's here what we are doing, maybe you can just you can have the parameter how to compute for this. If, for example, um, how the duration is that how long you are going to construct this project, this design. Okay, if that is in terms of computer engineering or other maybe electronics engineering, then maybe they can how many parts. Okay, for civil, of course, we are civil. Then we're talking about how long you can construct that. Okay, now there's another one which I think very important for all of us is the risk. Okay, risk, number of casualties. What could that be? It's part of our. I already told our faculty members to have it. Now, what could be the risk? Now, I think this can be just um, rating. Okay, rating. Okay, when I say rating, what do you think are the risks if you are going to do this design? For instance, if let us have this let us have this as our risk. Okay, um, the risk is that a risk that it might it might um, fall or deflect during construction. What could be possibility? So I think, do you understand when I say rating? You can just use rating. You can say 1, 2, 3, 4, 5. Okay, so that is a rating. But you also have to discuss your rating alongside in the just a paragraph or so. How did you come up with your rating? If there is an existing way how to do that, then I think it's fine. It's fine. Now, this one is an example that it can also be environmental impact, friendliness of the design, purity aware. So then you are going to measure the purity of the air. So you need to actually do that. Okay, but when we do this one before last 2019, we are talking about a project that can that can say, I would say that environmentally that can affect people working or even people already using the facility or your design. And another one is sustainability, design life in terms of years. So for civil structures, you can find it a lot. I would like it to use Google. Okay, I would like it to use Google. For example,
Huwag mong bubuksan
what
yan.
are the expected life
Oo,
of the building
sige.
to lifelong learning? Okay, that's the way to do these things. But you can see, you can appreciate really if you will be able to do this one yourself. There can be a lot of confidence, but I think even if you have those lot of confidence in you just have to be humble all the time. Okay, because other people may be knowledgeable than we are, so we always remain humble. What I'm just saying is that we always can do lifelong learning, always do lifelong learning, and give some muscles to our minds, to our brains. All right, so that we know already how to do this. That today we really scrutinize how you are going to do this. I hope you are doing this. If not, if you just put these numbers there, then I would like to ask you. I would like to comment on the paper. How did you come up with this? Especially if if make articulation or statements about this in your design constraint. So I hope we do all these things. Okay, so the design can be any design. So if this design is your one way, this one is your two way, And the number three is two-way, but flat slab. This one is two-way, but with beams all around the panel of the slab. Ala, just administrative call for a while. Not easy, right? Sorry for that intervention. So let us continue. Okay, let us continue. So hope you know how to do this. Okay. Now this one, okay, in terms of months, I think you just have to put whatever you have, okay, in terms of months, 7, 8, 9, whatever, okay, whatever. How long will it take that certain design, that certain design to construct? Now, that can design one, trade off one. I hope you now understand that when you do trade off one, you also have to include there right away. Say for example, if you are doing if you are doing moment resisting frame on one side and the other frame is on, you're talking about one way and so on and so forth. You have to integrate them in one run. In one run, okay? You have to integrate them. It's not that you have to do it one by one. No, it will take us a lot of time. You just have to appoint. You have to select. You have to select what are those that you are going to include in that uh, in that trade-off. Okay, in that trade-off, considering constraints in economy, in uh, in uh, in sustainability, in constructability, in duration, in environmental concerns, and the other one is also if you are going to do the same. For example, moment resisting frame. First, you have your one way. Second is that when that is two way, how it's gonna be. Okay, so that calls for the, I think we've been talking about that. Then that calls for how long you are going to consume that if you're talking about duration. Now, I think for that, while you are doing your capstone design one now, you have to do you have to apply here also your understanding here in capstone design, and you only have to use your the parameters that you are going to compute for the area. Say for example, if you have area of 1,000 square meter of the entire 5 floors, how long will you do that? If, for example, per square meter, you are going to do that you're going to do that 130 days. So you have to multiply it how many days. I think that is what we call parameters. Okay, parameter. So in that way, you will be able to determine how long. It's not that you just have to say it's 7 meters, 7 months. It's not that way. Okay, not that way. The way is that you have to specify deliberately what parameter are you going to use. Uh, if you can, okay, I worked for AI for some times, I think 5 more than years. So we are using something about that. Okay, so if you are going to do excavation, how long are we going to do that? If there are 10,000 cubic meters of volume, how long will we do that? So there are a multiplier, or I will say work or man hours parameters or equipment hours to do that. Okay, so you just don't say out of you just think looking at the ceiling, and in there you will say it's gonna be 30 months. It's not like that. So you have to articulate how long, and you have to put something there. You have to support it with that man hour parameter or equipment parameter, or what parameter is that, as long as it is fitting as long as it fits your measurement. Okay, so that's the way to do that. Okay, that's the way to do these things. And I think you are hitting two birds at the same time. You are doing your capstone design, and now we are also doing it in here. Although it's not the capstone design, because we are only doing one material. Now, if you are doing a capstone design, you can as well think about another trade-off in terms of using steel, pre-stress, timber, composite, many. Okay, many. Okay, so that's the difference between what we are doing. But the thing here also is that when you do the design of any structure, you actually do that. You actually do that. So I'm going to give this one to you, so that You can make this one as reference. So this is only what Abad gave us. Okay, but what about the normalized data? Okay, what if you will say, what if you will say, because all of us have biases, okay? What if you will say, I put this, you can see the equation. I would like you to study the equation. Okay? Anyway, the equation is here. Where is the equation?
Saglit lang.
Okay, I put this is how you are going to normalize. This is the equation. Okay, that's our equation. All right, so I think you don't have problems. So maximum minus actual and divided by max, then multiplied by 9 plus 1. So you try to normalize. In design one, for example, we normalize that one here. So that's how you are going to do it. Okay, so let us continue. Okay, say for example this one. So we come up with the design C8, okay, for a while. So C8, so this one, of that, right? Look at that one, okay. C8, C8 minus C8 divided by that number minus this, multiplied by 9 plus 1, okay? And that, look at this one again. Here. So, see, look at this one.
Magbibigay na ako. Sabi ako kayo na.
This one is C8, okay? C8 meaning that's the cell, okay? C8 minus C sub 9. What is C sub 9? This C sub 8 because you can say that that is your that can be your bias, okay? You take it for design one, okay? Design one. So we make it as your governing, okay? Uh, Governing trade-off, okay? C8 minus C sub 9, then C9 minus C sub 10. And another, so we take all from 8 and again minus that, minus this number. Of course, when you do that one for the for design one, if indeed this is the one that I would like, I would like to I would like to have, because it's 900. It's you do not consider, whether it's it's a large amount, is so expensive, but you think that 900,000 is good to you. Okay, I'll repeat. Look at that one. Okay, look at that. Okay, C sub 8. Okay, C sub 8. We make that one as reference for the entire, and we go through for each one of these, dividing them, referencing this one, okay, that one, the 900,000. What if, what if you're going to consider that one as 700,000, because is it's I would say the cheapest. Okay, I would say the cheapest. Okay, I think it's otherwise that I have said. Okay, cheapest. Okay, uh, the thing also here, the thing also before you have to decide here. Okay, I have to remove this one. Okay, I'll remove that. I think we understood already what are those things that I would like to share with you for this. Okay, you also have to consider. Okay, once we're done with this, once we're done with all of this, it's now up to you what in this what in this
Hoy, huwag kayo maglaro dito. Tapos kaya.
I would like to. Okay, anyway. Okay, and talk about all of this. Which of this do you think will be your choice? Would it be that I can say, okay, even if it's 900,000, but I know it's durable. But I think all of us will get directly to the cheapest and to the fastest and to the one which has lesser risk and to the one which have 98 because if it's 100 then you have 100 security, and if it's this one is sustainability, then you will be thinking about how long you can sustain it. Okay, so any question, let us ask first if you have questions about this. Okay, so I'll repeat. I said earlier that what if you have this as your Cs of 8, C8, C8 as the one. Okay, so you have to choose that and put this one here. Okay, normalization, for example, for a constraint number one. Let us check that one. Does it matter? Does it make sense? Maximum minus actual, maximum minus minimum, and all of this multiplied by 9, normalize it by 1 because if you are going to click the maximum, you choose the maximum, and what could be the actual? What could be the actual? That's a nomenclature from my point of view. Okay, okay, maximum, that's the maximum C8 minus that actual. Okay, these are all the actuals. Okay, these are all the actuals. Okay, for example, C sub 8. Can you see the formula equation, formula panel? Everybody, anybody, anybody, just anybody. Can you see the formula bar so that I can
Yes,
just.
sir.
Can you see the formula bar?
Sir po.
Okay, thank you. Okay, I'll repeat. Okay, I'll repeat. Okay, so this is a very important understanding for all of us, so that you can use this. Okay, um, how do we know that indeed later what could be the winning, what could be the you know winning, I would say winning design. Okay, winning design. Okay, winning design. Is it design one? Is it design two? Is it design three? Okay, nice. This one is a very nice exercise. You can readily adapt this. Okay, so without this equation, even me can be, we can, even if we do this one before, we can somehow forget. Okay, we can somehow forget the idea behind how we choose the how we normalize in the first place. Okay, how we normalize in the first place. So this is our equation. Okay, this is our equation. So let's go back to that. Okay, for example, for we're talking about this, we're talking about that. So that one is equal to max minus the actual, but the actual is is in itself this number minus the max again minus the minimum, which is the 700,000. So you get the extreme, you get the ratio of the of the of the max versus the minimum. Of course, we associate that one with your actual quantity, or when I say quantity, whatever is that. Is that the cost? Is that duration? Is that casualty? In whatever. Okay, in whatever. Okay, in whatever. Okay, so max, which is 900, and the actual, which is also divided by the max minus the minimum, which is 700, multiplied multiplied by 9 plus 1. So that's an equation. Okay, does it make sense? Think about it. So let's proceed to the next. Let's proceed to the next. The 10, that is our scale. It scale 1 to 10. So meaning the highest will give us the best. Is that right? If that is 1 to 10, then the highest will give us the best. Is that correct? So let's consider the design number 2. The identification. Okay, that's my way of doing it. All right. So here we know already that the equation is that your max, it's the ratio of the max minus the actual, and that the actual is the current, is currently where you are parallel to that. Okay, where you are trying to consider. Example, if this you are trying to do this number 3, so you get the max, which is c sub a, minus the minimum, which is this number itself. So it's 700, it's c sub 10 divided by, again, which of these 3 is the max. So it's the 900, which is in the c sub 8, a c8 in cell A8, in that you deducted from it the minimum, which is in itself c sub c10. So that's how we got this. Okay, and that's our normalized data, and so on and so forth. Again, what if you are going to consider 9? Okay, that 9. Okay, so 9. So d10, that is the max. d10 minus this, minus d sub 8 divided by, okay, divided by the okay, divided by the quantity max, which is 9, minus this of 8, which is 7, and so on and so forth. Now, because we deal with the extremes, and here, you try to do this. For example, here, which is the max is 4. Okay, so for example, I'm doing number 10. Okay, so E10, you can see that one here. E10, okay, E10, E10, okay. So it's E10. Can you see me? See me? Can you see my discussion? Barabad? Barabad, can you see my discussion? Can you see the cells that I am pointing? Anybody would like to inform me that you have seen what I'm talking about, that you understand what I am discussing to you? Anybody?
Sir, can you try moving your mouse? Wala pong gumagalaw.
Kim, do you hear me?
Yes, sir. Yes, sir.
All right. Do you understand what I'm talking? How to normalize the data? How to do it? Kyle, Bueno, can you? Yeah, thanks, Abad in Castillo. What about others? Bueno, can you hear me, Kyle?
Yes, sir.
Thank you so much. So you understand what I'm talking. So let us. So this is what you're going. This normalization, this technique of this technique of determining what what design trade-off that you are going to consider in the end is the one that we are doing right now. I should have not done this one for you because it's part of the custom design, but when I ask you, it was not taken up with you, then let us do it. Okay, let us do it anyway. um, do I still have time? Do I still have time? I'm going to attach my discussion. Okay. We're going to have quick quiz on Monday. On Saturday. It's only about slab, and I'm going to give you one example about this. Is that okay with you? That okay with you? Anybody? Thank you, Kyle. Okay, don't answer in chorus. For now, I just want to ask anybody coming. I'm going to give you quiz on Saturday. I just have to attach before your exam some example, maybe few example of how we are going to do a one way because supposedly we are going to discuss it. But I don't like you doing these things. You do not understand, and that's why we discuss this. So um, I just want I would like to just attach this one with you. Anyway, I'm going to show it to you. Okay, I'm going to show this one to you. Slab design. Okay. Before we end, okay, I'm going to show this one to you. And I prepared this for you, and that slab design. Notebooks. Wow. I'm going to give this one to you. Okay, how to solve. Please prepare for this. Um, I think you can just read through this. So instead doing this one today, um, we again embark on our fifth meeting for the discussion of our design report, so that at the end of the day, at the end of the semester, there will be no star grading that we have not discussed it. So I think we have discussed it so well, I would say, from my point of view, and that even if you did not ask it, I gave it to you. Basically because I just want you to learn. Okay, I just want to say, for example, if I keep on talking normalization and all of these things, and that I have not tried to discuss it with you, I think it can be just futile. Okay, it's futile on my part. Just keep on talking without giving it to you. But it should have been part of your constant design. But when I ask you that you have not, it's not been yet, it has not been taken yet. No, I am telling you how to do this. So we have this has eaten some of our time instead. But I think not really, because 6 hours per week for our one third of that supposedly should go to our discussion of our design report. But many times that I also have asked you, many times that I also have asked you, are there questions? But I cannot just say, if you do not have questions, then I'm going to make a conclusion that everybody understood. Okay, so I take it just like, okay, if you're not going to say, okay, all right, then I'm going to do it for you. Okay, so this is how to do that. Say, for example, you have a question like this. Okay, don't get confused. Okay, maybe you can be confused when one of the students said that they are confused when I'm doing the discussion. Don't get confused. I think um, don't get confused. Okay, when you are confused, is that there are no there are no things whatsoever that I have founded. Kumbaga, wala akong tinanim sa inyo na bago ako nagdi-discuss na masasabi mo na na-confuse ka. Pag medyo na-confuse ka, magsalita ka lang. You just have to ask question. Okay? So, example of I think na kukuha na siguro ninyo yung paggawa no, yung kanina. Pareho lang yon sa lahat-lahat. And through the and down, then yung isa na lang ang gagawin mo para ma-check mo ano ba talaga ang gagawin ko, considering four multiple constraints that I have seen at I have shown to you. Anong design ang kailangan ko? So the scale is up to 1 to 10, for example, then you get the highest. Okay, so 10 minutes to do this. So I have done this one for you. Okay, this is actually my quiz, and I'm going to share it with you now, that I just get it anywhere else. Okay, anywhere else in our um, I just got it. Okay, so it's a one way slab. You look at that one-way slab. So you have um, the cross section of a continuous one-way slab solid in a building is shown in figure below, like that. Because really, our building is always almost continuous. Always continuous. So the slabs are supported by beams that spans 3.658 between simple supports. The dead load on the slab is that due to self-weight plus 3.69 kilopascals, the live load is 6.22 kilopascals. Design the continuous slab and draw a detailed section. Bars 0.5 by 8, location B, okay, and that, okay, that. So, from anywhere else, so just have to read. I might be getting again from books that we are getting, okay? So determine the thickness of the slab. So this one, you have to be careful here. L over 30, L over 20, L over whatever L is that. Okay? Why is it L over 30? Because it's for the end of the slab. So you have to consider, are you going to consider a slab which is, for example, you have a slab, one slab, say for example here, slab, okay, slab, and that here you have 200, this one here you have 180, this one here is 120, and that is the reason why we consider this. Okay, so that you have your uniform uniform thickness for the slab, and also that has effect on the formworks. Okay, formworks on the beam sides, because the other one is thicker than the other. Okay, that's the reason why I choose L over 30. We choose L over 30. So 3.66. Okay, that's 3.66 here. 3.66. Okay, that's how we solve it. I think our discussion is very, very detailed, I would say. I put that one them all in for you to check on that. And I think it's just straightforward. So minimum total depth for interior, and that 135. So in this case, when I say 122 there for the end of the slab at this point, interior also, which we think we do not have like that, because it will affect our beam formworks. You are going to say in your solution, assume if that is 120 to 104, might be someone will say 125. I think it can be, you also have to consider the, if that is 122, you're talking about 125 only. What about the cover? Okay, what about the cover? But don't make it also that it can be too expensive for your trade-off. Okay, so that is how you can play these things in your manual calculation. Don't forget manual calculation. Okay, you will not make it if you have it. Okay, you will not make it if you don't have it, because that's our purpose, to enable you to apply all those calculations like this that we have. Apply that one in your, you can even if I am doing like this, if you have improvements on this, then I think there's no problem. Okay, you can do it. So Number one, determine the thickness of the slabs. Okay? Calculate the calculate loads and moments in a unit strip. So assume a 1 meter strip of slab. If that is in English, it's only 1 foot. Okay, only 1 foot, but it's for SI, it's 1 meter. Okay, so you compute for the dead load. Now, if I am not going to give you the unit weight, I would like it to use. I would like it to use. Did I put it here? I think no. I would like it to use 24 kilonewton per cubic. That one, okay? And you multiply it with your assume, which is 0.130, then plus 3.69, 6.81, then factor load. So this is part of the MU later that you are going to get from STAD. So that's how you are going to connect all our understanding into what we say right now, a digital way of computing, of designing or analyzing its structures. So how do we interface all of those in these calculations? So anyway, I've said that one already. So MU, instead that you will be the one doing this one, just do, maybe you can do a verification, just like this. But the thing is, if you're going to do STAD, I think STAD will give you the best, or the max, uh, from the several combination load cases. So it might be that you will have, but it's nice to do this in our design report presentation. It's nice to do that. Okay, so if this one is given, then you just do the simple 1.2 dead load plus 1.6. Then maybe you try to get later how much is the STAAD. Is the STAAD 20.38 kilonewton meter? That's very nice to verify. Okay, so that is the 1 meter that I am saying. So design of the reinforcement, solve for D. We do not know the D yet. Okay, the effective depth. We only have the entire depth as 130. So calculate loads and moments in a unit strip. We're done with that. The design of the, so you have a row balance. You can use this. Then you do the row max. And I think, look at, don't be deceived. You try to understand again from point of view of the beam design. You have your row minimum, row max, row balance, and row actual. Okay, when do we use this row for uh, the getting your desired design for or rebars. So what I did here is that um, I did the row balance. What do you think? What do you think is the reason behind? What do you think is the reason behind? Okay. Then I said row max. You get the row max and you apply this one here. It's very nice to do this, especially if you have done this one in your design report. So you compare that and put it here. So raw max for tension control 0.90, and I think I have this one as an example. Please check our example for flexural. I think I have this one for you. Then you use this. Then you use 69.33. Then you solve area of the steel, row BD, then 0.023. So where do we get the row BD? Let us check. So row max. So we use the row max. Okay. Now, I would like you to check this. I would like you to check if really this one yields. Okay, I'll repeat. I would like you to check if really this one yields. Okay? I hope you understand that. Okay, so total depth
Uy!
Total debt,
Sunod
you
yan.
got it here, 95.30.
Hindi.
So
Yan lang
it's
yan.
all right, 130, because even even our reinforcement can do 95.33, but there's another thing that we did in the initial. We're talking about serviceability limit.
Ano?
This is what we call
Ano?
serviceability limit. So the one that we have considered in this design is the serviceability limit. All right. So I just put this one here. So I manually solve them one by one. Okay. I solve them one by one. Okay. So any question before I end? So we'll have at least, I think, two problems about the two-way. Only two problems. Okay. Only two problems. We will do next week for the design of two-way shear, a two-way slab. Anyway, I think we can uh, before uh, before you have to do some refinements, then maybe we can do some refining discussions on Tuesday and on Thursday and Saturday. Then you submit that. But I do not know if the Tuesday discussion about design report can still help you. So I would like you to ask your anything, any question right now. Okay, please ask question. Okay, so I'm ending our discussion. So let's have our question and answer. Any question? Any question? Any question? If no question at all, let us check. Okay, I'll not check your attendance anymore. Even if I wanted to, I just want to say it's up to you. Okay, it's up